And a nice, easy, gentle introduction to Scala this morning. Two of possibly the scariest topics you could possibly tackle first thing in the morning, macros and shapeless. I'm not here to talk to you about programming, I'm here to talk to you about metaprogramming, because it's much cooler and more meta, and I need to point this at this, and it doesn't work. Technical problems immediately. There we go. Okay. So, what is metaprogramming? It's the practice of writing programs that write programs. So, from a Scala point of view, we can think of metaprogramming as giving the compiler instructions to allow it to write our code for us. Isn't that an attractive thought? Or possibly to modify our code and get it to do more awesome things for us. And I'm going to be talking about two specific use cases for metaprogramming, although there are many more use cases. We're going to be talking about getting rid of boilerplates and writing DSLs. Now, I said metaprogramming is about getting code to write code. It can also sometimes be about, okay, this is going to be awkward, but we'll do it anyway. It can also be about spending time working with libraries and possibly not getting the results you want out, because there are at least two different ways of doing metaprogramming in Scala, and those ways of doing things have different benefits and different drawbacks. So in deciding to do some metaprogramming, you need to pick the right tool for the job. So we're going to look a little bit at what works well, what works less well. Like, I'm going to move this off here. Oh, okay. Sorry, thanks. Is that going to work? Here. I think it's the lighting or something. Hey! Wow, you have connected a new keyboard. Go away. I don't need you. Okay, sweet. Brilliant. Okay, thanks. So we're going to look at what when the techniques work well, when they cause problems, or where they become complicated to use. And we're going to see some kind of awesome code and just see some tips to make things easier. Okay, there are two take-homes from this talk, two punchlines. So I'm going to spoil the ending before we begin. The first one is that macros are good for syntaxy things, and shapeless is good for typey things. So if you're thinking of a problem and you want to use metaprogramming, you want to get a nice DSL or something, and it's a largely type-related problem, that's probably the direction you want to go, shapeless. If you want to you have a syntactic problem, then maybe you want to use a macro. But the big take-home point is that metaprogramming is really just a nice, happy, thin layer on top of your programs. When you're writing libraries, you write the libraries in Scala, you solve the problem in Scala, and then you just put a little bit of metaprogramming on top. And that avoids getting involved deep down in the complexities of these things, and it means your libraries stay composable and stay easy to use. Okay, so that's the intro. So I'm going to give two case studies now. And we're going to look at some ways of solving things with metaprogramming. So the first one is about just constructing Scala values. So the use case here is I have a case class, something like this fine ice cream case class here, and I want to create instances of ice cream. But I'm lazy. I don't want to have to write constructors and put in the parameters. I just want to say, this is the type, make me an object. And I expect the compiler to fill in all the details for me. Okay, does that make sense? Yes. Cool, okay, all right. We had at least 3 yeses. Haven't lost you yet. So let's look at how we do this with macros. Okay, macros are all about taking pieces of code and rewriting them to be other pieces of code. So we tell the compiler, whenever you see something like this, rewrite it to be something like this. Now, I'm going to show you some macro code now, and I'm going to show you a little tiny bit of shapeless code. I don't want you to dwell on the details. The idea here is to get a feel for what we're doing, and because it's far too short a talk to learn macros or learn shapeless, right? I have a shapeless workshop tomorrow, so we can get into more detail about at least one half of this then. But the idea is we would do something like we would implement, I wonder if I can do this. Okay. We can implement our method using a macro. So here we've got create, it's going to return a value of a, and we're going to implement it using this macro. So whereas methods in Scala are to do with returning values and having types, macros are to do with returning expressions that produce values. So they're dealing with syntax. So here's the macro. That's a lot of code for a slide, but I'll sort of walk you through it. notice at the top here, we've got our type A, and we're returning not an A, but a tree. And a tree is an abstract syntax tree. It's an expression, a piece of code to produce a value of type A. And then we're going to use a combination of helper methods that I've written and pieces of the macro API to implement this. So first of all, we get this weak type of, we get some metadata about the type A, and then I've got a little helper method here that I'm not going to show you the implementation of, that takes that metadata and goes and looks at the class definition, because you can get hold of the class definition, finds the companion object, goes through all the methods one by one, and finds the first method called apply that returns the type that we want that's public. Then we look at we have this apply method. This is an object representing metadata about the method. We can look at the parameters. So we can iterate over all the parameter lists and all the parameters, and we can produce an expression for each parameter. And I will show you this helper method on the next slide. And then at the end, we can just build a method call. We know the method, we know all the parameters, and we can just splice this parameter list. So this code here, right? Macros are a pretty advanced topic. This code here, to me at least, reads pretty nicely, and we can understand, hopefully, what that means, right? It's not that scary, too much. So the key thing I want to show you is this method here, right? Create apply parameter. So this is the simplest implementation I could think of. We're looking at we take in the type that we're trying to create a parameter for, and we say, is it a string? All right, return an empty string. This has the prize for the most double quotes in a line of Scala today. If it's an integer, do a 0, and if it's a Boolean, do a false. And if it's any other type, just stop, just throw a compiler error. And we can customize the error message, but it's a compiler error. Okay? All right, so with that, we have enough to do this transformation, and we can implement this transformation for ice cream. So I want to look back at that and see, sort of think about what we've done. I think the code is relatively easy to understand. It would take a while to learn how to do that, but once you've got the code, it's pretty simple. Can anyone think of any drawbacks about the code I've shown you so far? Just shout out.
Easy to make a mistake.
It's easy to make a mistake. Yes, okay, it is fairly easy to make a mistake. There are lots of hidden assumptions in that code. I'm looking for an apply method. How many apply methods does the class have? Does it have a companion object? Maybe the constructor was called create because of some idiosyncratic reason. So there's lots of points of failure in that code. Anything else? Specific to, wait, use the right pointer. This method? Say that again? It's hard to add more types. Yeah, okay, that's my first bullet point. It only supports 3 types of parameter, strings, ints, and booleans. And what's more, the user can't add more types. So this is basically useless, right? If we ship this as a library, no one can ever build instances of case classes that use their own data types, because as the library author, we don't know what they are. And another point is people keep saying Scala Reflect is deprecated. This macro API we're using is deprecated. So we have to think about what happens when we need to port this to Scala Meta, when that eventually becomes the main way of doing macros. So I want to go and concentrate particularly on which pointer? This pointer, these parameter types. And I want to go and revisit this problem and see how we can do it better. Okay? So what we need is we need a way for the user to specify, given a particular parameter type, what default value we should insert into our constructor call. So the user can program rules to look up values by type. Can anyone name a Scala programming idiom that would do that? Implicits, yes, and more specifically, what use of implicits? Type classes. Okay, brilliant. So hands up if you know what a type class is, or if you've used one before. Okay, good. We've got a talk on type classes in just a minute. So anyone who didn't put their hands up, Andrea will show you how to do that stuff. So I've made a type class here, just to walk you through it. I've called it pure because there's an operation in cats that does the same thing we're doing here. It's called pure. It's a fancy name, but basically as a trait, we say, I'm going to have an instance of pure for some type A, and it gives us a method to produce an A, right? This value method. And then I've implemented it for the 3 types we care about so far, string, int, and boolean. They just return the 3 values we need. So how do we get this type class and put it back with our macro? Well, it's fairly simple, actually. The only method we need to rewrite is the create apply param. So I'm not saying if it's a string, do this, if it's an int, do this. I'm producing a piece of code, and by the way, no, this one. This is what the code actually says, if we get rid of the macro speak. It gets an instance of pure implicitly, just by looking up an implicit val that's in scope, and then calls its value method. So all of this root.scala.whatever is another brittle thing about macros. If I simply wrote implicitly here, the variable name takes on the meaning where the macro is called, when the macro is where the call to create is. So someone could declare a variable called implicitly and change the meaning of my code. And the way I'm getting around that is to just globally reference everything. And that's another gotcha with macros. So lots of sort of weird rules that you have to remember. Anyway, now we've done this, now we've got this type class, our expansion goes from create ice cream to this. And so for every parameter, we're getting the equivalent value that we previously hard-coded. This is now an extendable system, and we can ship this as a library. It'll handle any parameter type, but we've already seen, we've gone through a number of ways in which the code can fail, and it can fail for ways that we, the macro programmer, didn't anticipate, because there are so many corner cases. So what would be nice here is if rather than looking at apply methods and searching for the right methods and searching for their parameters and doing all this low-level syntactic stuff, we had a way to just look at the structure of the case class, get rid of all the detail, and solve for the fields in the case class. And that's where we can switch from macros to shapeless. So I'm going to really go fast over the definition of this in shapeless, but this is roughly, we're still using our type class, and what we're going to do is we're going to add another instance of our type class. So previously, we only used this type class to insert parameters to the constructor. Now we're going to use the type class to do the whole constructor as well. So rather than say, create an ice cream, I'm going to say, get me a pure for ice cream, and call its value method. So the way we do that, this is the most hand-waving slide in the talk, is we use a thing in shapeless called a generic. So generic is a piece of sort of magical machinery that will allow us to take an ice cream and turn it, just boilerplate free, there's a method to turn it into some big data structure. And the idea of this big data structure is it splits out all the types into something that we can traverse. So more or less, this is called an H-list, a heterogeneous list, but it's sort of a bit like a list in that it's a list of all the fields in the ice cream, but it's also a bit like a set of tuples in that the type of this thing has string, int, and boolean all in it. And because we can do that, we can then traverse that structure and produce an instance of pure. So we already have instances of pure for string, int, and boolean, right? We defined them on an earlier slide. Now we need an instance of pure for this empty list down here, and then an instance that will take a head and a tail of a list and sort of build a bigger instance. And we do that because if we can build an instance of pure for this whole list, then shapeless will give us an instance for ice cream. So this is the code, just to give you a feel for how many lines it is. Don't try and read it. So we have an instance for the empty list, an instance for a list with a head and tail, and then this thing is the instance that goes asks for the instance for ice cream that in turn uses the instance for the big data structure. That's the whole thing, right? Now, if you like this, more tomorrow. That's about a third of the lines of code as the complete implementation of the macro, just for what it's worth. So, all right, we've still got to use a customizable solution, right? It's still a type class. Users can program strings, longs, Java util dates, whatever. They can add all that stuff in. And now, in addition, if they don't want to use the sort of a macro, don't want to use metaprogramming to produce an instance of the whole case class, they can just write an instance of pure and bypass this whole system. So it's really extendable. And the key difference between the approaches here that I want you to take home is the macros are syntactic. They're working with what parameters do I need and how many methods have I defined and all this detail. And shapeless is just ignoring the detail and saying, an ice cream is 3 things. If I can find instances of pure for 3 things, I have an instance of pure for the whole ice cream. And so it's much higher level. So the big drawback people cite to shapeless is it's using implicits a lot. Implicits cause the compiler to spend time working out what implicits to combine in what operations. For cases like this is fine. If you deal with really big data structures, your compile times can get longer. This stuff is getting better as improvements to the lightbend and the type level compilers come along. Okay, so what wins? I think this is a good shapeless thing. I think this is a typey problem. It's about types. Shapeless is solving the problem at a typey level. And one of the key things about that shapeless stuff is that all of the metaprogramming is inside generic. We never really see any of it. We're just defining implicits, which is a sort of a regular Scala thing. And the code is shorter, and we don't have to worry about migrating it. Okay, so that's constructing values. It's just implementing it in 2 different ways and comparing them. I want to show you another case study now, which is about validating data. So this is, I have a library which sort of does this. It's called checklist. You can check it out if you want. Basically the use case here is, again, let's say I have a data type, and I want to validate that. I want to check an instance of an ice cream as a valid ice cream. So there are some things which are implicit in the types, right? Name must be a string, cherries must be an int. So the type system solves that for us. And then there are other things that I need to check at runtime. So this is a snippet of checklist, the checklist DSL, which says, I want to produce a validation rule for ice cream. I want to make sure the name is not an empty string. And I want to make sure the cherries field is greater than or equal to 0. And what happens with that is we can run it on an ice cream. So here we've got a bad name and a bad number of cherries, and we get a list of error messages back. Here's the key thing. The error messages, and this is a goal of the library, the error messages must tell you which bit of the data failed. So we need to have the name of the accessor method represented in the data. That's where we need metaprogramming, because otherwise we can't see a method name without runtime reflection or macros or something. Okay. So how do we do this with macros? Well, what we're doing is we're going to look at that accessor method and we're going to use it in 2 ways. We're going to use it as is on the right without changing it, and then we're also just going to toString it and get the string name of it out. And to sort of give you an idea about, well, to describe a macro, we have to describe what code we're producing, what we're rewriting this to, right? So to do that, we need to have a little look about how these rules work. So in addition to this whole thing being a rule, each component is also a rule. So this GTE0 is a rule. And I'll show you how GTE0 works. If I create that rule and then apply it to a bad number, it will give me an error message, but there's no location here yet. I can call this prefixed method, which consumes this rule and produces another rule that does the same thing, but puts whatever string I've defined in there. And I also have this, scary name maybe, but this contramat method, which basically allows you to zoom in on a piece of data. So if I start with a rule for an integer, and then I provide a function from an ice cream to an integer, I end up with a rule that takes in the whole ice cream, focuses on just the field we care about, and then runs all the rest of this stuff, so we still get the same result back. Okay? So what we need, so these methods, and no metaprogramming, nothing up my sleeves, this is just normal Scala code. These methods give us the functionality we need, right? Without any macros. It's just that they're quite long, and we have to say the name twice. So now we make the macro, we're going to turn field here into a macro, and it's going to expand to this and thing, which ands the whole expanded rule on. So this rule of ice cream actually creates an empty rule that always passes. And then we just say, all right, check this, and this, and this, and this. And then we end up with something that does all of the validation. So that's what our macro is going to do. Field is a macro, and it's going to expand into this larger method call. So this is looking at rule. This is looking at field. It takes in these two parameters and returns a rule. And we're implementing it using a method called field macro. So as I said before, just as normal Scala code is to do with values and parameters and return values, macros are to do with trees. So here we're taking the function and the rule, but they're both trees. They're both expressions. They're the pieces of code the user has written. And we're returning the new tree, which is our expanded form. And then to get hold of, so we have our accessor method, we have our rule. So this is the contramap thing, and this is the rule we're going to contramap on. And we just need to get the name. So we get the name by literally looking at what the user's written as this function, finding the name, calling toString, type safe, and building an expression from it. So it's literally just what you would expect. Very, very simple. So, and what that means is this macro only works if you write like _.cherries. It won't work if you write _.cherries something else. Like it'll be the wrong shape. But nevertheless, then we just generate the code. C.prefix here means whatever came earlier. So if I write rule.icecream.field, C.prefix is this, and then field will, and then the macro will expand only this part. So it expands into that. So this is a sort of a syntactic problem. When we're writing our field method, we want to sort of just, it's a very simple like, well, I want to write one parameter and I really want to treat it in two ways. And it's very simple, I just want to look at the name. It's a syntactic problem. So I think this macro solution works quite well for this. It does have restrictions. It will only work if we write a certain type of code, but it's very easy to bypass. Like if we have a situation where we can't use the field macro, we just use prefix and contramap. Okay, fine. 3 lines of code, not 1. The code is super easy to maintain because that was the whole definition there. It's like, 5 lines? And that's going to be a lot shorter than what I'm about to show you, which is the shapeless definition. So you can do this in shapeless. I found out how to do it the day before yesterday. And so this shows you the power. I'm really going to skim through this because it's cool, but So what we do is we can use another piece of toolkit in shapeless called a label generic. So if the generic gets you sort of splits out all the types of all the fields, label generic splits out all the types of all the fields and tells you what they're called. And the weird thing here is that these are types. So we're looking at something which looks like, so this is, I don't know, some people probably haven't done this. If you write a single quote and then something, it's a symbol in Scala. It's like, like if you do double quotes, it's a string. Single quote at the beginning is a symbol. It's just another data type. And so shapeless is saying, hey, look, this field, it's called name and it's string. And this name here is actually a type. So you can sort of search for an implicit for this type with name and string, and it will only work if it will only resolve if you're searching for the right name and the right type. Anyway, whatever. So the way we write the code is this. We actually do it differently to the macro case. Rather than specify an accessor method here, we say, this is the field I want. And shapeless will say, shapeless can then, because of the code we're about to define, can say, is there a field called name of the type that we need inside ice cream? So again, it's structural, right? It's looking at the fields and seeing what they're called, as opposed to looking at method names and just seeing what the string values of them are. And okay, look, this is the code, right? So this is the method call. It uses an implicit. This is the definition of the implicit, and these are all the instances we define. And yay, square brackets and lots of less than colons and stuff. Doesn't matter. In this instance, I think, do you get the feeling that that's quite a complicated solution to the problem that's very easy with the macro? Do you get that? Yeah, I think that's what I want to sort of say. In this instance, we have a very syntactic problem, and we're kind of fighting the problem a little bit because shapeless is requiring us to formulate it as a sort of a typeful problem, and that creates a little bit of an impedance mismatch. So macros win, short code, again, easy to maintain, easy to replace, easy to not use. The biggest thing about this whole library, in my opinion, is that you don't need to use any of the metaprogramming. Okay. All right, so I've given you two examples there, and hopefully sort of one example seems like a nice shapelessy thing, one example seems like a nice macro-y thing, and the difference is whether we care about more syntactic things, the code the user has written, or whether we care about the structure of our types. So if you're looking to add metaprogramming to your library, this is your first port of call, like which way do I go, left or right? But the other thing we should note is that really, I spend a lot of time talking about type classes and cool method calls and all this, and not very much time actually talking about, well, we went through the macros in quite detail, but not a lot of this code was macros or shapeless. So my sort of, this is the quotable slide from the talk. I think with all this stuff, we can do 99% of things in Scala with case classes, with sealed traits, with type classes. These are the important patterns. And the only time we need to switch to metaprogramming, be it macros, be it shapeless, be it code generation, runtime reflection, whatever. No, let's not say runtime reflection. Whatever metaprogramming technique we want, if we've built our library correctly and we're using idiomatic Scala, the metaprogramming becomes a lot easier. So for the sake of the video, here are a bunch of things. So there's a lot of self-promotion in here. So I did a talk a few years ago called Macros to the Rest of Us, which is like a newbie's introduction to macros. Toma here has a talk on using macros for validation, which I found the other day, which is kind of awesome. And of course, the Chris Birchall's Metaprogramming and or Shapeless All the Things talk, best talk title. I wrote a book on shapeless. There's my plug for the book. You can get that for free from here, and that's the talk of the book. And Sam Halliday did an excellent workshop on shapeless if you want a good deep dive on how to use shapeless for doing JSON encoding. As like an hour-long video from him. And then I've talked a lot about building functional libraries and making them accessible as the first step towards making any of this work. That validation example I went through, I did 2 different talks on going from nothing to a working validation example, so you can sort of follow up on that. And then my colleague Noel has a great talk on what he thinks people need to know to program Scala with the sort of implicit assumption you don't need to know anything else, which sort of just these 6 things, these 6 weird tricks. I've actually ended up with 2 minutes left, so that's amazing. Can I show you, before I do thank you, can I show you my favorite macro ever? Okay, more self-promotion. This is my favorite library, what I've ever written. Have any of you ever written this? Strip margin. Who likes strip margin? Put your hands up. Okay, good. No, out. Strip margin I find unfathomable. It's runtime solution to a problem that can be solved just by having a better literal support. So unindent, you do this, and it gives you an I interpolator, and you don't need to write strip margin. It does it at compile time. You look at the code, it's like 20 lines. It's a lot of regex matching. It's super simple, and I think it's a beautiful, beautiful example of this syntactic solution to a syntactic problem. Anyway, does it break IntelliJ? I don't think so. No, don't think so. We can try it later. Okay, thanks very much, everyone.
Thanks, Dave.